this is a particular style of question that I think is a good idea to have a look at because it is using your knowledge of equivalent fractions, but you're applying it in a slightly different way. So normally we ask you to find equivalent fractions for one that we give you or match it. Okay, so either say yes, it's equivalent or no, it's not. All right, in this case, they've given you a whole different bunch of equivalent fractions with the intent that these all become equivalent to each other, but there are bits missing. Okay, so the first thing you've got to do, these are all separate questions, question 1, question 2, question 3. What do you think would be the most sensible thing to do first? Let's look at just the first question. Akira?
What the common ones?
Great idea. Yep, you would do that, but before you do that.
Well, you should look at whatever fraction is actually completed
Awesome.
to see how much.
Yeah, so your base fraction to begin with is going to be the one that has a numerator and a denominator already. Okay? So in your books, just write equivalent fractions as a little, or EQ fractions. And then just the first example. Okay? And I'll give you a sec just to write all 3 questions down and then we can do them one after each other. So I can actually hear people talking through the question already, which is great. Okay, but we already spoke, the first thing you need to do is to have a look at the fraction that is already complete. Okay, and then usually you'll be able to find one other part of a fraction that you can start to work with. So you've got actually 2 choices in this question. So you can then go to this fraction, try and work it out, which I think would be a really good idea for this question. Or you can work out what this numerator is. What do you reckon this is for?
16 times 16 is 3 times 30.
No.
Can that just be like whatever other half you want? It means to say 12 and 24.
Any equivalent fraction that you wish to make up for that one. Okay, but first, I think this would be a good idea to go this way. So what you've got to think about is, what have I done when you have 2 numerators? What have I done to this numerator to make it into this numerator, which is equivalent? So when it gets smaller, you know you are dividing. Charlie?
You do the same to top and bottom.
You do, yeah. But what have I done to 2 to make it into 1? Not subtracting or adding.
Divided by 2.
Yeah. So what I do is I put what has happened next to it, the direction I'm going. Okay, so that way. And then I know that I have to do the same thing here. So 4 divided by 2.
2.
Okay, so now we know that the lowest fraction here in my equivalent fractions is a half, and that makes the rest of it really easy. Okay, so what should I put here? 8, yeah. So I've times this by 2. This 4 by 2 to get, sorry, that's not right.
4.
This
By 4? Yeah, 4 by 4 is 16, and then 2 by 4 is 8. Cool. And so you could put anything here, providing that it is essentially the same as a half. Someone give me an equivalent fraction to a half. Charlie, again.
16 over 32.
Yep. Okay, and what Charlie's done there is that he's just doubled this one. It could be 50 over 100. It could be 25 over 50. It could be 7 over 14.
I did 250 over. Already got
Now, I would suggest, it goes without saying, hey Maxie, that you wouldn't put one that's already there. There again.
Wait, that's
Technically it's correct, but I would say that's not really showing your full mathematical knowledge.
Nobody said you couldn't.
Mr. said that.
Okay, I'll say it now, don't do it.
You can put 12 out of 24, you put anything
I'll
that's
give you a
half.
big cut 0 if you do that in the exam, Maxie.
0 is half.
Okay, so here we've got the complete fraction happens to be the first one of 3/4. Okay, so I asked myself, what have I done to 4 to turn it into 16 by multiplying? Okay, and so whatever I do to the top, do to the bottom to the top. 3 times 4 is
12.
And it's always good just to have a look and go, yeah, is that right? Yes, it is.
Yes.
Okay, now when you go to this one, this is the danger that you have with stuffing up this question. Okay? If you go and look at 12 and try to make it into 21, by multiplying, it's not really possible to get a whole number. So you're probably thinking, well, how am I supposed to do this question? We have actually done these before. You need to go back to another fraction that you can see you can change by multiplying or dividing. And so this, from 12 to 21, is not really happening. So 3 to 21 is
7.
Times by 7.
Oh, then you divide that.
Do I times this by 7?
No.
No, this one. Okay, because it's the same fraction that I used. Alright, so times by 7. What's 4 times 7?
28.
Awesome.
Yeah.
Got the idea?
Right.
Yeah.
Well, I just worked it out because I knew my 4 times 4 fingers.
Yeah.
Yeah.
Same thing. How did you make 12 into 21 then?
I didn't. I just put 28 because I knew that was my 3.
Oh, okay. Yeah. Alright, now this one you're actually going to be dividing, you're going to make the numbers smaller to find your equivalent fraction. Okay, so this is my first one here. Again, going from 24 to 16 is a bit challenging with division. So you would then look at the other pairing that you have, 21 and 7, and I can do that way. What am I doing? Dividing by 3 to get my 7. So 24 divided by 3. Can we do it?
Yes.
8. Excellent. And now that I have this pairing, I can go back the other way. 8 times what?
2 and then 14.
Okay? So just because they are set out in a line like that, Maxie, just because they're set out in a line like that does not mean that you have to progress step by step. As long as you're making sure you're using the complete fraction to make another complete fraction, that's fine.